So for this one, again, we're looking to see, is x plus 2 a factor of 4x squared minus 2x plus 5? And again, we want to focus on using synthetic division. And I know it's still kind of out there for a few people. We'll get you caught up. But this is one of those, because there's so much dividing of binomials that go into algebra and pre-calc, it really does speed the process up to use this algorithm. So I set it up by taking that negative 2 that's up here. So I put that in the box. Now I grab my coefficients. So 4, negative 2, and 5. Now I follow the algorithm. So I bring it down. So bring down my 4. Negative 2 times 4 gives me negative 8. And that's negative 2 times 4. Add it. So negative 2 plus negative 8 puts me at negative 10. Oops. Negative 10 times negative 2. So go up over here. So negative 10 times negative 2 puts me at a positive 20. Negative 25. That would be my remainder. Correct. So I say this is not a factor. Because if I were to write this out, I'm looking at an answer of 4x minus 10 plus 25 over x plus 2. Because remember, your divisor is the basis of that remainder. Because in the other problem, I'll go back just for a second. If you look, my remainder was 0. So I don't have to write plus 0. That's built into it. Right. But here I had a remainder of 25. So this also means that x plus 2 is not a factor.
If it is a factor, you don't have to write x plus 4 on the bottom.
Right.
But if it is,
then you would.
But
Guys,
if it's not, then you won't.
Right. Now there's one more thing I want to add to this conversation. Say I wanted you guys to evaluate p of negative 2. That would be taking 4 times negative 2 squared minus 2 times negative 2 plus 5, right? Yeah? That would be evaluating p at negative 2. So that's going to be 2 squared is 4 times 4 is 16. Negative 2 times negative 2 is 4. 5 is 5. The remainder you get from synthetic division is the same as the function value at that point, which is what y would be when x is that number. Yes, it's a great way to check your work.
Could you always use that, like the second kind of way every time, or is it so no matter what it's right, it's only you do it correctly?
Yeah. So like, for example, when you're looking at a problem that says find f of x for x to the 5th, 812 x to the 7th to the 6th, blah, 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 blah. If you do synthetic division using that number, the value you get as your remainder is always the function value at that point.
Which is what they put in semicolon there in parentheses.
Right. So you don't actually have to do all that work to get there. Well, you gotta do something. You gotta do one of the kinds of division. Yeah. Well, if you want to, you could flip this the other way around and say, I like doing all this plug and chug. If you put in whatever you think the factor is and you get 0, well, you know you've got a factor or a root. Because remember, we talk about these functions, the roots are where y equals 0, right? Which is where the remainder would be 0. So these ideas all blend together. They all work towards that same goal. So again, here I can not only tell you that x is x plus 2 is not a factor, I can tell you the function at -2 will be 25.
There's actually two numbers then.
Right.
Multiply together, they get that number.
Exactly. Factors are numbers that when you multiply, or expressions that when multiplied together give you the same result. Yes. Okay. Hope that's right.